Okay, so today we will start talking about the analysis methods. Just an overview, because each one of these methods will take a long time to completely understand. So, at the level of for environmental analysis, one needs to know two things. The objective of doing this is to is a selection of method, and then it also helps in your preparation of samples. In other words, you can tailor your sampling methods to the instrument that is being used based on a selection of the method of analysis. Okay. Because there are a large number of options available, and sometimes the selection of method is governed by access to the instrument and also the cost and the logistics of doing it. Sometimes it may be very difficult to do some analysis, sometimes you do not have access to it, so it is sometimes prohibitively expensive. Second, it may also help you in sampling methodology. So, preparation of, if you know the method, what are the methods available, you can also prepare. Then the third is data analysis, and what we can also call as interpretation of the data. This requires you to know something about the instrument. So, you do not need to know how the instrument works and how it can be optimized. You need to know at least what it is giving you and whether it is reasonable, it is what you are looking for, or it is reasonable, or it is completely it's pointing in some direction that it may mislead you. So, you have to know a little bit of the overview of the instrumentation for this purpose. Okay, so, this is the objective of doing it, not to give you complete information about the working of one instrument. So, it will take you an entire course to just look at one particular type of instrument to understand the intricate these things. So, our goal is not to do that, it is just to give some overview of what are available then and why is it used, simple. So, this is this thing. So, in that context, so and we will also look at different analysis. So, last class I had mentioned, so we have standard methods, and I will go over that again, of analysis. So, the three things are important in the standard methods is the analysis of or measurement of the pollutant in matrix using an analytical instrument, using a technique. So, this is what, so if you know these three things, that constitutes one complete methodology that is used to doing it. So, we will go from, we will go back to our analysis method. So, we are looking at water quality. The way we are going to do this is, first I will just do certain things that are specific to water and specific to air, and that is done. Then we will move on to something that is more generic. It applies to all matrices, and then looking at examples of some of these. So, water quality. So, we are looking at the first thing we look in water quality is screening parameters. Screening parameters, for organic load we are looking at BOD and COD. Mainly. So, BOD is as we had discussed briefly earlier, is biochemical oxygen demand. We had discussed some of this before, let us go over this again. Biochemical oxygen demand. So, usually there is a time below the BODs. It can be anything, but typically time in whatever units. So, typically it is days, but it can be anything. So, the way the BOD works is there is a standard method for it. The standard method is using one of the methods, standard methods for BOD is method number 5210 from compilation. This is called as a standard methods for the examination of water and wastewater. I think this is there are methods, a large number of methods in this. I will show you the website. So, in this method, according to this method, and this is a very generic method, and there is a what is known as a BOD bottle. It is so designed such a way that this is the typical volumes of this bottle is about 300 ml. This is all standard. So, you have to understand that this you can do this whichever way you want, but because it is a standard method, the objectives of many of the standard methods is for people to be able to use it without any prior knowledge of this particular thing. So, for example, I can do a BOD analysis in whichever way I want as long as I understand what I am doing and why I am doing. But there are a lot of people who are just analysts who will just come and do blindly, they will analyze the sample. For them, this standard method gives you all instructions, step by step instructions. You follow blindly, it should give you the correct answer. You do not have to apply your mind to it. So, there is something called as a BOD bottle, which has a volume of 300. Okay, volume of 300, when you completely fill it, no headspace. Okay, the reason it is called a BOD bottle is because the measurement of BOD is essentially the dissolved oxygen at initial time t equal to 0 minus dissolved oxygen at some time. This is essentially the biological oxygen demand. Okay. So, it measures 0, this initially DO0 is initial. So, the BOD analysis, the way it is done is a 300 ml sample bottle. So, you take a sample from somewhere, you are taking water from say a river or a lake or anything, you fill this up. So, you have a the analysis of BOD is dissolved oxygen at 0 minus dissolved oxygen at some time. So, 0 is the initial DO or dissolved oxygen, and DOT is the DO at time t. Now, at 0 t what we do usually is there is a DO probe that is placed in the into the water. So, this BOD bottle is so designed that the standard DO probe goes nicely in this without allowing any air to pass in or any oxygen to escape, and then you measure and then you take it out. So, in this you can also see that there is a lot of chances of error associated with it, because you are talking about oxygen. So, there is, if a reaction is going on here, oxygen can also be consumed and oxygen can get infused. So, the idea is you close it, you open it, put the DO probe inside, measure, wait for the DO reading to show up, and once you are satisfied with the reading, you take it out and close the bottle again and keep it somewhere. This is the idea. So, in this time if there is a loss, you have to check for that.
So, the water won't go out?
You assume that water is not going out. So, that is the idea, that is the other thing. So, so you have to estimate how much water is going out. As you are pulling in and out, some water will stick to the probe and come out. So, if out of 300 ml, if people are determining so So, usually what they do is they will fill it up, they will almost overflow it, then they will take out slowly, or sometimes you can just leave it as it is, but it is not convenient. So, DO probe is expensive, you can't have one DO probe for every DO bottle. That will be nice to have, it is sitting in the probe bottle, but unfortunately we do not have that many DO probes, you have to take it out and use it for 100 other samples. So, I think some of these probes can cost up to I think you can get a cheap probe for 50,000-60,000 rupees, but it can also go up to maybe a lakh or more. So, depending on the characteristics of the probe. So, those are quality control questions, I think. So, if you think they are important, you have to worry about corrections for that, otherwise it does not matter. So, the volume is not really important that much here. The only way volume is important here is if it creates a head space, then it is a problem, because oxygen will now go and equilibrate there, and available oxygen for use in the BOD is not enough. Okay. So, then once you do the initial thing, you take the BOD bottle and incubate it for T, whatever time T is. So, typically T is 5 days, in the standard method T is 5 days. Now, this is not set in stone, this is also not a fixed thing, because it can vary from waste to waste, it can vary from the composition of the waste. So, what happens in T days is the microorganisms that are present in the water consume oxygen to degrade whatever is the organic compounds, called as this is for the degradation of organic compounds that are present in the water. Yeah. So, you have to, what are the possible errors in this? We talked about quality control, what are the possible this thing. So, after 5 days you take out and measure the probe DO again. So, you are going to get a decrease in the DO from the initial to the final, which means that corresponding to the amount of organic load that is present, there is a certain amount of degradation that has happened. Oxygen has been utilized for the degradation of organic compounds, and therefore, this difference is expressed as that is BOD, oxygen demand. Yeah. What errors could be there in this? So, it is not, I am not giving you full information, this is not standard method, means they will tell you everything, you know, whether you should move your hand this much, keep it there, keep it here, all that, everything is included. So, a lot of missing information here, like I give you a BOD bottle and a water sample and a DO probe, what will you do? You will add this, take the BOD, then what do you do? Where do you incubate it? The word incubate means it is kept at, what are the different things? We are doing biodegradation here, right? We are doing biological degradation. Then you have to think about what are the things that affect biodegradation, and also things that affect oxygen consumption, the oxygen in the water. If we talk about biodegradation, one thing that biodegradation is influenced by is temperature. So, you have to keep it at some temperature. So, this BOD can, different biodegradations can happen, rates that can happen at different temperatures. So, at 5 days I can consume one level of oxygen and it can change if my temperature changes. So, you have to standardize this, you have to tell everybody that all people do the incubation at some temperature and not do it whichever temperature you want. So, if I keep it outside, temperature in Chennai is 35-33 degrees, and temperature in somewhere else, some other part of the world is different. Temperature in Delhi in the winter is 20 degrees, 30 degrees difference between Chennai and Delhi, all these things are there. So, you can't have that. This is what we call a standardization. When we say standardization, it means everybody follows the same method, which means you have to do it at some temperature. Typically, the temperature is 25 or 30 degrees. I think the standard method asks for 25 or 30? 20. 20, sorry. It is 20 degrees centigrade. One may argue 20 degrees never happens in India often. Indian temperature in South India is always 20 plus night or day. It does not really apply to India. So, that is not the point. The BOD is a surrogate measurement, it is not a real measurement. It is already a surrogate measurement because it is measuring oxygen, it is not measuring organic compound. it is also a reference point at 20 degrees centigrade and for 5 days. So, you have to understand it in that context, that you have to map this to an actual concentration of some chemical. So, the value of BOD is to give you a parameter that will indicate the quality of water, that is all. So, there are standards based on this to tell you that if the BOD level is above some value, the water is considered to be unhealthy or considered to be polluted. So, these are all the same reference. This is important why everybody follows the standard method, irrespective of, if you do not have the equipment to follow a standard method, you should not call it a standard method. You should say that I measured DOD at 35 degrees centigrade using some other instrument, or you can develop your own method. So, it is not standard method of BOD, that is all. So, because everything will change, a lot of things will change. And the second problem is that you can also get oxygen production by photosynthesis. If something is there in the water, including microorganisms, including some biological matter, which will contribute to oxygen production during photosynthesis, you do not want that. You want oxygen neutral systems in reference to that. So, that will cause problems. So, when you are only looking at oxygen demand for degradation, this entire thing is done in the dark. You put it away from sunlight, so dark. Okay. So, there is another problem here. These are general two conditions. For very highly polluted water, you can use T as 1 day and all that. So, that is also possible, but everything else remains the same. But typically when somebody says BOD, it is BOD 5 days, 5 days of incubation. Okay. The third, another factor that influences the analysis, the results for BOD is, what if you do not see any change, or you see very small change? Does that mean, what could it mean? Two possibilities. If you see very small change in the oxygen content of the between DO0 and DOT, what does it mean? What could it mean? There are no microorganisms. Bottle is not sealed properly. Why? But oxygen is not changing from initially, means oxygen is not going out anywhere. It is not been consumed. Only there are no microorganisms, that is one possibility, that there is no microorganisms in the wastewater to do the biodegradation. That is one possibility. So, what is the second possibility? No biodegradable organic matter. That is there. Is there another possibility? No biodegradable organic matter. So, that covers it. So, there could be organic matter, but it is not biodegradable. So, it is quite possible that it is non-biodegradable. It is biodegradable, but does not contain no microorganisms. If it is non-biodegradable, you can't do anything about it. You can't use this method no matter what. But if there is no microorganisms, can be addressed by adding microorganisms from outside. So, this is called as seeding. We will seed the system by adding microorganisms, which are again standard, but this is more tricky because standard means somebody has to sell you those microorganisms. They tell that this is even more trickier because there is a specific species of microorganisms, and microorganism profiles in different places across the world are very different. It may be very different here compared to what is there in 10 kilometers away from here. There is a wide variation depending on what is the substrate available here and all that. So, that is a very complex problem. People do not get into that. So, instead they will add whatever is available. So, this is again not standardized, but I think you have to be very careful when you are doing the seeding. You have to do with all references must be made with the same seeding. This is a bit of a tricky thing that we will not get into that. So, that analysis of that requires you to analyze the population and all that. So, if it is generally there is some recommendation of a seed, but people may not have access to that sometimes. They will just add whatever is available. So, what we call a general microbial populations. So, the idea of a seed is that natural waters have some microbial populations that are there already. So, it will degrade. So, the idea behind BOD is that it will degrade by itself, things will biodegrade naturally, which means that you have to rely on whatever is there naturally. It need not be one particular bacterial strain or microbial strain, it could be multiple, a family of them. Depending on what is there in the water, they will something will survive and will grow, metabolize whatever is there. Okay. So, you seed. So, let us say that so ideally what you would hope is that at the end of 5 days all your biodegradation is done, finished, and so you start. So, we take an example. I will write the example in the next page. Let us say that DO initial is 9.8 milligrams per liter, not 9.8, 6.8, and DO 5 is 1.2. It is very straightforward. BOD is the difference between these two, 6.8 minus 1.2 over. Suppose I get, instead of this thing, DO0 is 6.8, DO5 is 0. What does this mean? What could this mean? This 0 is a problem, because in our case of when we are doing calibration, if you recall, calibration, we have response versus mass or something. If your calibration does this, the 0 is equivalent to this part. I have no idea where this is. What does 0 mean? 0 means all oxygen is consumed, which means 6.8 grams of oxygen can be consumed by some x grams of organic load. What if there is 10x organic load? Okay. So, 6.8 milligrams per liter worth for 6.8 milligrams liter multiplied by 0.3 liters is the amount of oxygen you have in there. This corresponds to x grams of organic load. What if there are 10x organic load? You have no idea, it will still be 0. Once this x is gone, the remaining 9x is still sitting there, your analysis is incomplete. Yeah. So, what do you do? Huh? That's BOD 5. Is there an easier method? What if it happens in the first 10 minutes? No, whenever we do this, what do? If you have a signal response like this, if you are in this range, what do we have to do? We have to bring it into the range where it is measurable. So, what do we do in this case? We dilute. So, we dilute. So, here how much will you dilute? If you 10x, you are diluting at least 10 times. You bring it below 6.8. Below that range where it is going to happen. So, I will dilute it by a large amount. So, I can do multiple dilutions. This is what people do. They have no idea what the concentration is. They will dilute 10 times, 20 times, 30 times, 100 times. Somewhere this value will be above 0. So, then they will take that value as the reference. So, if you dilute this, if I dilute say 20 times, and my DO5 is 1.2 milligrams per liter, my actual DO will now be DO0 minus DO, my BOD will be 6.8 minus 1.2, but this 6 minus 1.2 corresponds to 1/20th of the sample. So, I have to divide by 1/20. 20th dilution. This is the dilution factor that goes in there. So, this actual BOD of the sample is 6.8 minus 1.2 is about 5.6 multiplied by 20. typically this is what is done. You do not have very few samples which are BOD of 15 and 10 and all that. So, it is always more. So, dilution is inevitably done. So, the standard method equation straight away, the standard method equation is DO0 minus D5 DO5 divided by what is called as P. P is known as the dilution factor. In this case it is 1 by 20. So, you have to
what is used for dilution? Distilled water or?
Yeah, good question. So, you use it is called, what you use for dilution is dilution water, whatever you call it. Now, this could be whatever is the purest water that you have. Now, what is the quality control here? So, there is a matrix effect. Now, if I am diluting 20 times or 100 times, which means that in the 300 ml sample, 300 ml the bottle, 3 ml is the actual sample, rest of it is my dilution water. Yeah. So, the dilution water is a matrix, is the water. So, now you have to check if what is the BOD of the dilution water. This is a matrix blank, this is a matrix blank, you have to do this matrix blank, because the water you are adding for dilution can have a BOD of its own. So, you have to calculate that separately. You have to calculate that separately. So, this must be subtracted, something must be subtracted from this. It is the DO, is the change in DO of the blank of the dilution water. Yeah. How much value is that? So, that you have to now divide that and then do the dilution. There is another possibility that the seed that you are adding also has its own BOD. You are saying it is microorganism, but it may also accumulate BOD. It may also have some consumption going on. So, along with this blank, if you are adding a seed, you put that seed also, you put some amount of seed and then calculate the consumption of oxygen for these. So, these are, so this is the quality control, this is the QA QC blank, the blank term goes here. So, you do not consider that as part of the sample, it is part of your method, your sample dilution water or the seed or anything else, oxygen leaks, all these are like the way we do with blanks, what we do with blanks, the false positive and all that, you have to do here also. If you want to look at leaking of oxygen across, the way we do is we have a standard. What is the standard here? What could be a standard? There is no standard here. What is the standard here? Oxygen is the standard. We are measuring oxygen. So, you have to calibrate the instrument using oxygen. Your dissolved oxygen probe is measuring oxygen from one point to one point. The DO probe usually, so we operate at, which means you have to make standards at multiple concentrations of oxygen, very, very difficult to do. Okay. So, what people do is they have maximum, what is the maximum concentration of oxygen in water, that is the highest you can get is the solubility, saturation. So, they will bubble oxygen or air through water for a long time, 1 day, 2 days, they will measure, keep measuring. What is the solubility of oxygen and what dissolved oxygen solubility roughly? 8 ppm. 8. It is around, yeah, between 9, 10 around that milligrams per liter. Do not say ppm is a very, I would suggest you use absolute units always, because there is a lot of confusion, ppm, ppb, ppt and all that. If you forget, you make a mistake, it will cost you 1000 factor of 1000. Milligrams per liter is around 10, 9, 10, at 25 degrees, 30 degrees is around 10, 8, between 9 and 10 depending on the water. So, it is not very high. Okay. So, you can make it, so whatever you get the highest value, if you know what that value is, you keep it at 1. The other end, you completely remove oxygen from water which is also not easy because you are now exposed to oxygen. Whenever you expose water to oxygen, oxygen always wants to go in. So, you have to purge the oxygen out of it. There are ways to do it. One way is to add an oxidizing an agent that will react with oxygen. All oxygen can be taken away. There are methods to do it, we will not go into it, but you have to prepare this, and it is not trivial to prepare this. One way is to just purge with nitrogen. Nitrogen will remove all oxygen, and that is one way of doing it. It is a lengthy process, it takes time, this mass transfer of nitrogen using oxygen, and then that is one end. So, you have a 2-point calibration. The 2-point calibration is very dangerous, but that is the best you can do as of now, because anything else in between is not stable. Oxygen is, by the time you prepare everything, system, open it, put the DO probe, gone, it is not the same, different. So, it is a bit tricky. Okay, any questions? This is just a overview of this.
Sir, we are keeping seed for consumption only.
Yeah.
How will that interfere?
No, so sometimes the seed may also have, you are taking seed from somewhere that could have some organic load that will also consume. Microorganisms, when you are collecting it, practically it may have something else in it, unless you are using pure culture and all that. So, this is it may or may not give you any value. So, this is the same. Quality control is done just to ensure any such artifacts. Sometimes it may be important, especially because of this dilution factor. So, the reason if you are using dilution factor of 100 and all that, any small error there will magnify by 100 times here. So, that is the reason why we are worried about small things like this. So, otherwise it is not may not be a big issue.